So let me briefly introduce you ROB4FAM, which means Robots for the Future of Aircraft Manufacturing, which is a joint laboratory between Airbus and Stasse. So the aim of this joint lab is to allow partial automation of such kind of environment. So here you have a huge plane where a usual big robot is performing some drilling and screwing task. And the problem with this kind of robot is if they don't work, which actually happen very often, they are cluttering the whole space and they are very costly. And you may have heard about Boeing, which currently removed all these kind of robots after trying during 7 years of having automated lines for their planes, and which actually was giving more work and burden on top of the worker. So actually trying to apply this kind of approach, the car factory approach, is not working in the in the airplane industry. So for this, what they want to have is a mobile versatile robotic cells, such as this mobile robot here, which is currently trying to do a screwing behavior. And the aim of this lab is to use all the techniques that we have developed for human robots and apply them to all these mobile manipulators in order to make them more versatile. So here you have one of the application that has been done for Airbus, which basically is currently doing deburring for pylon, which is currently a piece connecting the airplane engine and the wing. So here you can see that the robot knows 3D model of the piece as a sequence of all he has to do, and he's able to plan in real time a sequence of motion in order to bring the tip of the driller inside the holes of the pylon. So the problem is that when you do it on the real robot, what's going to happen is that the robot has flexibilities. So despite the fact that you have planned the tip to be at one specific position, the tip in reality will not be at this planned position. So you need to compensate for that using vision. So we use basic vision using classical QR codes, and we hope that with the other technology developed inside the Anity or Prairie, we will be able to have a more intelligent perception. But here you can see that the system is using this vision to generate a control law which compensates for the deflection. So you can see it's going to up to 5 centimeters and here successfully do the tip. So it was accepted to case 2020, and the fundamental scientific part has been accepted to transactional robotics recently. Thank you very much for your attention.